Welcome to the final session for the CENIC Conference 2019. I'm so delighted to have you here. I'm Camille Crittenden and Deputy Director at Citrus in the Bonato Institute based up in Berkeley, but I'm also a proud co-PI of the Pacific Research Platform, and it's been a real honor and educational experience to work with Larry and Tom and my fellow co-PIs over the last several years. We're really pleased to be here this morning to give you an update on where the Pacific Research Platform is and to let you know a little bit more about where the project is going in future years through the National Research Platform. So my role in the PRP has been to work on communications and outreach and science engagement. I work closely with my colleagues at the Berkeley Research IT division, and it has been a wonderful experience trying to understand better the scientific workflows for faculty members working in these data-intensive fields. So part of what we wanted to do over the last recent year or so is to build on the basis that John Graham had created through the website for the PRP and make it a little bit more visually appealing and organized so that people coming to it could find out information that they're looking for. So if you go to pacificresearchplatform.org, that will redirect you to a UC San Diego site and then also to a GitHub site where the work has been posted and will be more easily updated, but also looks very nice. And also a shout out to Leanne Weber at CENIC, who has also been quite helpful on the design side. So here's just a summary of a little bit of what I was just mentioning about the organization of the website. I know that the PRP, we've been discussing it for a number of years now, and you have the full technical description and output described by Larry and by Tom on various occasions. But if you want more information, here is the way to get it. And it includes all kinds of information about workshops and events and documentation about how it all works, and updates around the science engagement team meetings and such. So part of our strategy for getting the word out about the Pacific Research Platform has been to hold workshops of various kinds and in various locations. So just as one example, recently in the last 6 months or so, we held a workshop at the UC Santa Cruz Silicon Valley campus in Santa Clara that Jeff Weekly helped to organize and others on the team around AI workflows for astronomy and microscopy. So the astronomers have maybe been more in the forefront of trying to figure out how to harness all the big data coming off of these instruments and moving it into their supercomputing centers or their labs for analysis. And we found that gradually the microscopists are also looking to figure out this workflow. And so we wanted to bring these two domain areas together and have them learn from one another. So this was a really exciting event. Ilkay Altentosh, who you might have heard from yesterday, was our keynote speaker. She did a wonderful job of presenting some of the data science and organization behind it, also using the Wi-Fi project as an example. And then we had a lot of time for other presentations and Q&A and sort of community building around data science and these data intensive areas. And you can see the slide decks on the website. So here's, oh, I guess that was the same slide. Oh, all right, there you go, twice. And then there are just a few photos from the afternoon. So we had three panels, including people from various institutions, UCs, LBNL, and others, and then Ilkay as the keynote speaker, as I mentioned. Another project that I'm really excited about that you perhaps also got a taste of if you went over to Atkinson Hall yesterday afternoon, is the visualization facilities that we have at UC Berkeley, building on the collaboration with the work that's already being done at UC Merced. And as an example, a project in digital archaeology that was pioneered by 4 campuses, UC San Diego, UCLA, Merced, and Berkeley, where we were creating this cave environment on a smaller scale than what you saw here, but originally at the Hearst Museum of Anthropology on the Berkeley campus, and then we're building out a new one at the Citrus facility in our tech museum in Sutarjadai Hall. So shout out to Chris Hoffman and his group, who's been very helpful in putting that facility together, and then also developing the content behind it. We're building on the work that he's already done at the Hearst Museum, using photogrammetry, and also engaging students to do some of this work, which has been a nice way also to engage undergraduate teams in doing that. So here's some photos of what it looks like at our tech museum, which is very similar to the setup that they have at the Hearst Museum as well. And so we're looking forward to using this as a test bed, also for some of this high-speed data flows between these visualization environments, also working with the environment at UC Merced as well. So here's a little bit more of the technical details about the back end and the possibilities that we want to use it for. Really, as you've probably seen and heard, there's huge interest in VR and AR kind of applications for all kinds of academic disciplines. And at Berkeley, I think we could engage faculty members in, earth sciences and astronomy, and other kinds of applications, also including the students who have their own VR club and are quite interested in the science behind it and the technology to develop it. One thing that I will just mention is that we are now looking ahead to the next year. Here we are in March and thinking about what we might do in the early fall, say. And one area that's really come up frequently is this issue of secure data storage and computation. So we're thinking about having another workshop around this, especially for big data that might need to be protected for sensitive data. So we are working to pull together a workshop on that, perhaps working with the folks at UCSF or at the medical center at UC Davis, which is one of the Citrus campuses, but we'll probably also host it again at the UC Santa Cruz facility in Santa Clara. So please let me know if you have ideas or thoughts about that. We would really welcome everyone's participation if this is an area that you're concerned with or have ideas about how best to help us develop. We're also working together with Internet 2 and the other regional networks. We have regular video conferencing calls. Tom leads one on the technical side once a week, and we have one on the science engagement side every other week or so, depending on conference schedules and such. But this has been a really good opportunity to engage with some of the research engagement staff from Exceed champions to people who are just individually working on their campuses in this area. Dana Brunson is newly at Internet 2, and so I will be working with her to help organize these calls going forward. So likewise, let me know if you would like to join the list for that. We'd be happy to have you there. We often have someone who can present maybe a use case for 10 or 15 minutes, and then just discuss other issues where we can kind of crowdsource ideas about how to further the cause of research engagement and science engagement on our campuses or through the regional networks. And with that, I will turn it over to, who do I turn it over to? To you. Okay.
Good. Okay, great. Hi, I'm Tom DeFanti, and thank you for staying to the last session. This is quite a group we put together for the Pacific Research Platform and its follow-on activities, which I'll very quickly describe. There's only a few people who are actually paid for in terms of FTEs by the PRP, but there's a lot of people who have, are working with us. You've seen this slide many times. The things I want to remind you, especially for those of you who are struggling to deal with all of this, is that Larry and I started out this with letters of commitments from both 50 researchers on 15 campuses and 32 CIOs. And that was the basis for it, which is one of the reasons, and this is 5 years ago, right? This is one of the reasons this has been successful, is because we actually worked up both legs of academia, right? Not trying just to do it all from a CIO IT service side or whatever. And we did win the CENIC Innovations in Networking Award 2001-06. I have to say the reason we could do this in the first place is CENIC was in place. We didn't have to build it. We did have to debug it, but we didn't have to build it. So here, I have a new award. It's called the TMI for PowerPoint Award. And this is a slide. It's on many of my slides because PowerPoint fails us. PowerPoint, is older than most of you. Here's another one. This shows that we have everybody talking to everybody, and we see places where they're not talking so well, and we go and find them. But you can't see. Here's another one. So here we have every bit of flow going from everywhere to everywhere. And you can, the nice part about this thing, and let's see if I have, yes, I did. So there's a slight difference between these slides. And what happened is that when we did this first snapshot, UC Santa Cruz was the major user on the in the PRP. And we said, wait a second, that's anomalous. And we did find out they were being attacked. That was from looking at this. And then the next day they shut that off, and the attacking thing, which I will remain nameless, and we shut it off and it all went back to normal. So we did that. We got the networks working. We, it was a new 100 gig CENIC network, and we basically got it all working. Got things working in 9.7 out of 10 and 37 out of 40 and like 90 out of 100. And but we found that scientists really want more than bandwidth tests. They really need to share their data at high speed and compute on it too. And we weren't doing that. And so we decided to do that. It turned out we envisioned this, and it was in the program execution plan anyway. So commercial clouds are not cost effective for sharing big data. It costs too much to share big data. They weren't designed, or at least not financially designed for that. So the PRP v2 is adding 2 petabytes on 11 or 12 of the Fionas sitting in your campuses, and another 2 petabytes at San Diego State that they got an NSF award. We're also adding GPUs, and so we have 3,000 CPU cores and 300 GPUs, which is over 1 million GPU cores, gives us 25 million GPU core hours a day, alongside the Fionas on these partner campus DMZs. This allows us to drop the cost of all of this by an order of magnitude over what you have to pay commercially. And is by forming a community of people who are actually doing the local support or helping and a lot of automation. And we are totally focused about enabling data science research and applications. As I said at the end of my comment at the last presentation, is that it takes time, though. It does take time. A lot of our success stories are 5 years in the making. We set up a rocket chat, and this is not a thing to learn from. This is a thing to get help from, although we've got a student project trying to figure out what people's questions are and create chatbots. So when you get on this, a robot might answer you. It's kind of cool. So we've had a couple of real success stories, and this one's been going on for a few years. When Scott Sellers came to us, he was trying to operate on moving data from NASA and compute on it. And there's a long presentation on this, but right now we're up to 532 times speed up in his workflow cycle. From 19 days to 52 minutes, and we think we're going to get down to what, John, 5 or 6 minutes, something like that. Yeah. Another guy, Jules Jaffe here, has a camera which we hooked up off the pier, and it's grabbed 1 billion images. Now, most of them don't have much going on, and the way you used to do this is you had grad students look at it. You can't hire enough grad students to look at 1 billion images, so will use automated machine learning. And so they go find things that are interesting. And then the grad students look at them and classify them. So this is the current state of the CENIC-centric Kubernetes cluster. And it's on 16 campuses now. And every day these numbers increase. So I've had to modify my slides every day in the past week. And this is pretty successful. The ones in red are for HP-REN only, and they're actually off the grid of the rest of them in terms of they're a high availability cluster for the wildfire work. John and I do these road trips. We drive around with $100,000 worth of computers in our car and sprinkle them in places, hook them up, and you see we have smiles. That's because I told them to smile, but anyways. So why did there's a, kind of a religious war going on now, sort of about Kubernetes and other approaches. We jumped on Kubernetes because last year, a year ago, 3 months ago, at Christmas time, the Spectre bug came out, scared the hell out of us. We realized we had 200 systems to update and freaked out. And so John figured out how to, if we started turning everything over to Kubernetes, John and Dima, then we could patch them overnight, which is important for scaling and our sanity. It also gives us sophisticated policy-based scheduling and reporting. And databases, every week there's a new database integration milestone. This idea of namespaces fulfills the cooperative research groups concept that we got from the Dutch, from Kees de Laat and Leon Gomans in our PRP proposal, and was a deliverable to take people and put them in their own groups. They didn't have to worry about interfering with other people. It works very, very well. The biggest and most important thing, I think, is that it allows the user jobs to scale to heterogeneous platforms, which means they're desk-side machines, rack-mounted machines, supercomputers, even IoT edge gizmos, which are coming on very strong. But for a lot of people, especially when their campuses want them to move into clouds, it goes right into the Amazon EKS for Kubernetes and to the Google Kubernetes engine. And we have not yet used the Azure Kubernetes service, but the prediction, it should be straightforward. We just have to somebody ask us for it. And it supports the latest version of TensorFlow, which is a big deal. Okay, and this is a John Graham quote. It allows us to manage petabytes of distributed storage and GPUs for data science while we measure and monitor network use. And that's a big deal because we need to measure and monitor the network use, and we need to containerize all that so it doesn't get in the way. Chris Paolini has another one, TMI for PowerPoint award, and the slide that he created for us and how he uses Kubernetes. And there's some of the too much information. Here's some more, and even some more. And you can look at these slides or ask us for details. But he really did build this big MPI thing on top of everything else, and that's very cool. Okay, so the next one. 2 years ago, we connected the 70 UCSD Suncave and 20 UCM Wave screens. And this year, we added those 90 GPUs to drive them to the PRP for machine learning computations. So this is leveraging resources that, when you're not staring at them, can be used for computing. And we're, in fact, doing that. And what happened was about 2 weeks ago, the IceCube neutrino people through Open Science Grid noticed that we had some resources. They grabbed 120 GPUs and running them in the background. And I calculated this would cost almost $3,000 a day in a commercial cloud, or $20,000 a week. And one of these 8 GPU Fiona 8s cost $20,000 to buy and ostensibly last 3 or 4 years. So there's a real economy of scale to play in our community infrastructure. This is another one that I forgot to put the star on. Frank Werthwein has been working comparing GPUs and TPUs. Now, GPUs are a transitionary, technology. And we've got a lot of them, but we're working to go to the TPUs because they're faster, lower power consuming. They don't work for everything, but people are figuring this out. Another place we're going with is Fpgas because of the power and the speed reasons. So here's IceCube using our Wave and Star Cave GPUs. By the way, those of you who came over yesterday, we shut them off, and we can do that in a few minutes. And then they, as soon as we release resources, they go glowing them back up again. So you can see that here. I don't have a pointer, but over there about the far end of the screen, their usage goes down to almost nothing, and that's when we shut them off. And then we start doing a demo, and it worked. And then so we did that yesterday. It worked again. Just to give you an idea, we do have this stuff monitored out the wazoo. And here's another example of where they were using all these things. You can see the usage is relatively parallel. And over the last little bit of each graph, it goes down to almost to zero. And then Isaac started running the demos, and the usage goes back up. So this is all moving along. You can see Osg was using 44% of our GPUs there. And we're learning how to be social by doing instead of by legislating. This is the Osg Data Federation. It is now essentially merging with the PRP and its V2 and its facilities, which is giving us a huge leap into the national and even international by us combining our resources and our scarce people, our few FTEs. So this has started out with the PRP, and then we added the, this is now the TNRP, which is towards the National Research Platform, which up top, if you know all those acronyms, I do, but you'll get a huge bonus. So we're bringing people on as they can connect and learn to do mad dashes and trace routes and the other things. And we did get a nice grant from NSF to add a couple FTEs to all of this the next 3 years. Okay, so the tech that's coming, we're supporting these augmented reality, IO robotics, little GPUs, these little boxes, that's really small, it's nothing. And the NVIDIA Jetson Xaviers. And then there are finally data center capable FPGA boards. And what does that mean? That means you can actually reboot them without having to stick your finger on a button. And we're seeing a lot of take up of those. They also happen to have 200 gig connectors out the back. And so this is allowing us to build a software defined exchange with P4 in those campuses there. And this has just started. We're going to have a conference June 5th and 6th here. If you're interested, let me know. And then we're doing TensorFlow cores and TPUs. So this is my last slide, I hope. So great networking with 10 to 100 gigabit science DMZ performance proven is a necessary but not sufficient condition to serve data-driven researchers. They need science DMZs and DTNs with lots of storage, low-cost storage, encryption, large RAM we're finding, GPUs, TPUs, FPGAs, and high available computing. That means computing that's got redundancy, so it can be mission critical for the people who are actually running real-time mission critical things instead of generating research papers, or in addition to generating research papers. Measuring and monitoring at all levels is key to the better usage and security. You would be surprised at staring at these graphs all the time in your brain, how the anomalies pop out and how you find things. And we've got people all over the place with their eyes on this stuff. We're being compatible with the clouds and the supercomputer centers because the PRP's only got a year and a half left. And what are we going to do after that? Go sit it all over there, right? I mean, we're going to do something so it doesn't just drop on the floor. And the convergence with Open Science Grid and Slate is happening. It's upon us, and it happened much faster than we thought. So we're really very happy. And this is my mandatory thank you slide to NSF and our other partners. And did I stay in time? Okay, good. Okay, next.
Thanks, Tom. So while Anne is getting plugged in, I just wanted to introduce Anne Kovalchick, who is a CIO at UC Merced. And she's going to give us a little bit of a broader view about the PRP and science engagement.
Okay. No, I got to run through here. All right. Good morning. Yeah, I'm going to go way up the stack a little bit and knowing that I followed Tom and his slides, mine are a little bit less dense and more symbolic. And what I want to talk about is how UC Merced has attempted to drive adoption and integration and service design around PRP projects. And I'll start with these. I'll briefly cover these 4 use cases, but I want to kind of ground you here because I'm going to work back to them over the course of the slides. Mike Dawson is a professor of biology and does a lot of work on marine biodiversity and has a Catalyst grant. So his lab is hooked up to the PRP, allowing him to do a lot of collaboration, of course, with other researchers, both within the UC system and outside. And currently we're working with him on developing workflows around real-time collection of environmental DNA. Erin Hester is a new professor as well, or actually not as well. Mike has been at UC Merced since the beginning, which, by the way, we are in our 14th or 15th year, so in the throes and drama of adolescence, very much as an institution. Erin Hester has her lab connected to the PRP. She does a lot of work on geospatial analysis. Again, very data intensive, large data sets, a lot of pre-processing and visualizations. Joel Spencer showed up recently with a $1 million microscope and then which he uses to examine live images from mouse models. He's looking at live streaming videos. He needs to look at those images within a short period of time because of the life cycle of the structure of the data that he's looking at. And then Alexandra Maines is in our School of Social Sciences and Humanities that had a really simple problem, but it was a big bottleneck for her, and that was moving large video file formats from Children's LA Hospital. She does developmental psychology, and of course these were videos of children, and so there's quite a number of security concerns around that. So having given you those 4 somewhat simple use cases, I want to kind of step back a little bit and underscore that in getting those use cases up and running, we've had to spend a lot of time sort of dealing what we have called the social engineering problem. This is something that I've seen noted in a number of reports. We talk about a lot. We all at this conference have discussed some of the challenges around getting adoption and dealing with the ability to scale and replicate within our organizations, that there are particular sets of challenges around dealing with the people side of things and the organizational side of things for less resourced institutions. There's a lot of internal challenges, whether you are an IT shop or research computing inside of IT or outside of IT, how IT interacts with the rest of the university, with funding, with research. And so here, I'm here as a CIO to really kind of comment on how we have approached that. And this really reflects my thinking about how a CIO can function to make sure that the PRP is integrated and adopted in a sustainable fashion in the institution. And this is really the crux of the transformational change we're trying to achieve. So this is really about executing towards that. And I have this quote here from John Hagel, Deloitte Center for the Edge, pointing out that transfer change is really a political process. And it's political because it's messy and people are irrational and they're often sometimes, quite frankly, stupid. And I don't mean that in a pejorative sense. It's that things are that complicated that we have a lot of things to make sense of, and we have to be willing to deal with the politics around that and help kind of find that sense making. And some of the ways to do that as a CIO, I have found is you simply have to claim jurisdiction over areas. In our academic environments, we tend to be very consensus oriented. We're all wanting to collaborate. That is important, but sometimes you have to step in and just claim ownership of a problem, knowing that you're taking on a problem. One of the things that I did in my organization was sacrifice an operational FTE and allocated it to research computing, because I knew if the operational stuff went downhill, I was probably going to be able to still get help. But I needed to get the research components and the organization up and running. And so I gave away FTE, and that actually gave me jurisdiction over that function, which had been divided into the schools and not really scalable and not able to reach the critical mass. And having given away FTE, I then appeared very wealthy and was given back another FTE. So again, that's sort of the political context we have to keep in mind. Stuart Brand, who I'm sure many of you have heard of, is actually still around saying some interesting things. And he talks about pace layering, and I think it's an interesting concept. It's this idea that change happens quickly at the edge, a little bit more slowly, not necessarily at the core, but at the other end of whatever the construct is. He uses the example of pine needles in a forest change quickly, but the crown a bit more slowly, the tree patch or the tree stand even more slowly, and then the forest and the biome, many, many hundreds of thousands of years. And so we tend to try and push down to those slower areas of change, and rather than push down, I think we need to pull out. We have to recognize that those slower environments that change more slowly are important. Change gets all the attention, but the slower parts of our organization have all the power. In this example, we see our friend Jeff here pointing out that he needs some attention to deal with a problem. My network engineer, Nathan, is like, no, slow down, wait, you got to fill out a ticket. I got to understand this. We've got to do some analysis. We've got to track this. This is the reality that we live in, and I think it's important to, while these are points of frustration on occasion, they're really also opportunities to build the relationship between fast and slow, because as we troubleshoot these problems, they require the documentation in detail so that we can, again, institutionalize what is fast, what gets our attention, into something that's repeatable. And I think we therefore have to keep in mind that there's two kinds of complexities that we deal with. The detail complexity, which is the sheer number of variables that we're often having to deal with: appliances, machines, devices, application, lines of code, people, roles, projects, consortium, collaborations, institutions, memberships, governments. So each one of those are variables in our world that we have to kind of manage. But then the dynamic complexity is the relationship between those many variables, and the relationship itself is a thing. Those relationships change, they're strong, they're weak, they're multiple, they're singular. So thinking in terms of which kind of complexity can be helpful in organizing some of these challenges we have in a systematic fashion, which compensates for the fact that largely we're working in messy political environments. We don't talk enough about books, I always feel, and so I always try and recommend a book in my presentations. And this is an old one. This is from about 2000, although there's been a revision as recently as 2017. But I like this book, and I highly recommend it because the authors point out that the challenge isn't often recognizing the innovation, it's transferring it. So transferring that best practice, and I see this as going to be a continuous problem for us in the PRP and the NRP, because we are often starting with institutions that are wealthy and have a lot of resources and trying to transfer to institutions that are less endowed. And in doing that, those transfer mechanisms don't always transfer seamlessly. This is often because we have to recognize the different social contexts of these institutions and the people in them, and think about then how to modulate, and often that means recognizing embodied knowledge. And the authors talk in this book, The Social Life of Information, about embodied knowledge, and the wonderful example they give is a typesetter at the Oxford University Press spent all his career typesetting Greek manuscript, and he saw an error one day. And he didn't speak Greek, no Greek, and so nobody believed that the error was there, and they kind of blew him off. And he insisted there was an error, and finally an editor came in and looked at the typeset and indeed found an error and said, "How did you know you don't speak Greek?" And he said, "I've been setting Greek type for all of my career, and I have never seen these two characters together. I knew they were wrong." That's an example of embodied knowledge. Now, that's an example of embodied knowledge that is, in a sense, was helpful in that respect. Often what we face is embodied knowledge that is not helpful, and we're challenged to train and to reset. For example, the faculty member who goes and buys a storage array to stick under their desk. I mean, they've been doing that for years. Why would they do that? That's what they know. That's how they solve their problems. So we have to really look for that embodied knowledge as entry points to change the culture. We did that with email servers. We can probably do it with server arrays. And I think this slide, although it has nothing to do with the PRP, I like to use it because it underscores how culture is visible to people and how we have to really recognize when we can leverage it as leaders and change agents. In that top picture, it's a picture I took when I was in Morocco during Arab Spring. And then I came back, and that bottom picture is the CEO of Douala, a startup, who claims that Che Guevara is his model for change too. So Che Guevara in the startup committee is like kind of a iconographic symbol of revolution, which is ironic if you really think deeply about it. But the point is they've appropriated that. And I think we have to think about in our IT work, how we appropriate faculty and academic leadership symbols of culture in order to find inputs for change. And some of the ways we've done that, and I'm kind of a sucker for the semiotic square that kind of plots oppositional forces. We took with Mike Dawson, because he is a faculty member who has been at UC Merced for a long time and had many poor experiences with IT, was not terribly interested. He was willing, maybe, but not really trusting that we could help him. Our entry point was the graduate students, training graduate students. And now we do that, and we approach this problem regularly. Graduate students, depending on the discipline and the faculty individual, their training is slightly different, but we know at an organizational level that we can kind of standardize training there as an entry point to expose faculty to the PRP resources and concepts. With Alexandra Maines, she had a request. She needed, to solve a data management issue, and she called IT. Well, when you call IT, you get someone at a service desk who sends a ticket, who sends it to someone in infrastructure. And so it sat there for about 4 months until it got escalated to me with great hysteria. And we realized, well, the problem here is we have no specific channel for faculty to make requests around research data needs. And that specific channel needs to have an escalation that goes directly to, in this case, Jeff. There may be things that come into that channel that aren't appropriate, and he can shovel them elsewhere. But again, we wanted to standardize the entry point very clearly for faculty on how to get that problem solved. We found with Aaron that, again, and this is a result of really 3 years of me coming to the dean's meetings and talking about the PRP, they finally thought, well, maybe before we hire faculty when they're on campus, they should talk to you. And we said, yeah, that'd probably be a really good idea. And so we have started this process of interjecting ourselves into the faculty hiring process and working with the deans and the chairs to make sure that we're on the schedule when faculty come to campus. And that has helped us preemptively identify needs, as well as certainly gives faculty kind of the white glove treatment. And then Joel, similarly, he bought his $1 million microscope, moved into the vivarium, and found out he had no network. And the reason he had no network is because the facilities folks said, you're in a vivarium, you can't make a hole in the wall, the mice will get out. So these are kind of the micro narratives. And again, this is a cultural touch point. It's a micro narrative that has lived forever. And we, said, no, that we can work around that. And so not only were we able to get the network into the vivarium for him, but again, working with the deans, we have now codified the startup package agreement to ensure there is pre-discussion with research computing and IT about the needs. And again, in all of those cases, it was myself who went and said to the provost or the deans, you know, you just spent $1 million and you can't do anything with that. Had you consulted with us beforehand, we could have, you know, we could have helped there. So I would be careful to not disregard the complaint-driven approach to adoption. Surfacing those complaints and those problems can be really important. You just need to be able to use them and leverage them. The biggest problems I see are when we try to hide the problems, because then they get disguised and no one wants to resolve them. So I'll leave you with this. It's a 6-step model that I also encourage folks to use. And this is a model that can be used with faculty, with your IT, administrative, network enterprise engineers, with your provost, your deans. It basically assumes that most change that's going to happen on a campus is going to happen because it's personally meaningful. It has to be really meaningful. And to most individuals, there's a series of steps. And often, it starts out with zero awareness. There is simply a lack of awareness. So you have to establish sort of where on this model the individual you're dealing with may be. It's an iterative model depending on what change you're making, and you can come in at any point. But once you get past awareness, you get to information. Do they have the basic information? Is it even relevant to them? If it's not relevant, if you can't make it relevant, then you're not going to get past that. Then you go on to personal issues that individuals have to deal with. Is this, you know, a conflict for me in some way? Does it make me feel stupid because I don't understand it? I mean, this is a highly, you know, what's the gain for me? So these first 3, awareness, informational, personal, are really about how the individual integrates and understands and internalizes the change. And then you go on to management, which is really about the task. Is this going to take me more time? Am I going to have to do something differently? Am I going to have to rearrange stuff in a different way? Usually solvable, but very task management oriented. And then 4, 5, and 6 really gets you to impact. You know, what's the consequence on this for myself and my peers, my collaborators? If I do something differently, is my collaborator going to have to do something differently? And how am I going to help that person do something differently? And then finally, refocusing, which is really where you get your impact and your adoption. So I would say, as we move forward and think about how we are going to roll out these new solutions, these new workflows, these new processes in this complex dynamic environment, to think about where on this model your individuals land, and can you tie them back to those cultural touch points and really then get that sustainability to reform and reset the embodied knowledge that many of our faculty and our leaders, our academic leaders and so forth carry around.
I could do it.
Thank you, Anne. That was really a great contribution and very enlightening. So to wrap up the session, we're going to invite comments from Louis Fox.
So first, I have to say why I like working with Anne so much. You know, it's this wonderful combination of anthropologists and Chicagoan, where stupid and complaint can be non-pejorative and can be generative and provide you necessary context and positive outcomes. It's wonderful. I'm going to go off script for just a sec. And particularly, it's been a long time since I was on a campus, but about 15 years ago, probably the most meaningful science engagement project that I recollect from my own experience was when we got together, several of us in the IT organization, along with the chair of computer science at that point, who was contemplating an eScience Institute. And we sent out our staff in 2 by 2 with sort of an interview protocol to go out and interview faculty and researchers or graduate students. The faculty didn't want to talk to us, who were most productive, and we define productive in terms of, awards, amounts per year of grants and contracts for over 5 years and so on. It was about 300 or so faculty. And the goal was to go out and try and learn what they were doing in their research and where they saw their research going in the future. Not necessarily sit down and talk about how much bandwidth you need or what kind of gear do you need, to really understand in a deeper way what they were doing and to develop relationships. And what happened from that was those researchers, or in some instances clinicians, had a contact, and it wasn't always the right contact in the IT organization, but they had developed a bit of a rapport, and in some instances even a trust relationship. And then that IT person could hand off whatever the question was, if it wasn't in their domain, to somebody whose domain it fell into. It also helped surface what were the most important things for this nascent eScience Institute to be focused on. So it was a really, and it built this bridge, a necessary bridge anymore, between large IT organizations and a very large campus and numerous faculty researchers. But I'm not supposed to be talking about that. I'm supposed to be talking about all of this Pacific Research Platform from a network point of view. And I have 5 kind of simple points about those of you who are involved in regional networks or on boards of regional networks. Sort of, what is it that we contribute to this effort that came from our research community? So 5 things. Number 1 is, of course, the network environment. In our case, it was not just CENIC, but it was Pacific Wave, which is partnership of CENIC and the Pacific Northwest GigaPOP. So sort of the network platform, and a number of kind of interesting things that go on. And once I start talking about technical things, you should know that I'm channeling one of the sort of trinity here, our holy trinity of PRP, DeFanti, Graham, and Hess. And in this case, it's John Hess. We have piloted various abstractions for selectively announcing routes for data-intensive science DMZ resources. And that was sort of a critical change. We also, with Pacific Wave, had a broad reach beyond the region, with high-speed connections to other regional networks, national and international partners, and relationships with those partners. And they include ESNet, Internet 2, MREN, NCAR, NCSA, not just networks, but facilities. Great Plains Network now, OneNet, Hawaii, Learn, NISERNet, Kimber, and so on. And those turn out to be very important for extending this platform and ensuring that the research community and researchers can continue to collaborate using this platform with people who they were already working with, or could get access to facilities and tools and resources that they needed. Number 2, community engagement. We contribute staff effort, but we also listen to the folks who are involved in PRP. We have technical advisory councils for CENIC, and it is a way for us at a more abstracted layer of a regional network to hear from folks who are on campuses and who are actively involved in the research community. Engineering support and research engagement. Number 3, our staff are intimately involved in this activity and in the calls, and are seen as partners in the overall enterprise. Extending from that, number 4, workshops. I mean, John participated in the workshops just prior to this conference, and there have been a number of other workshops that Tom and NSRC and others have put together to help export some of the concepts that underlie the Pacific Research Platform. And the 5th is advocacy. This is our role as we collaborate with our partners at regional, national, and international convenings and as I'm doing now, to just sort of talk about why this has been tremendously valuable support that we provide, but it's also been valuable for us as a network because it's helped us think about what is it really to have a scientific network, and what do we really need? And honestly, it's been in some ways very illuminating, even economically, because we were doing a lot of things that we probably can simplify because we've learned these things from the researchers and what they really need and what we really need to support as a regional network. I mean, it turns out that a thoughtful layer 3 network is a really good thing, and it is really meaningful to a research community. Go figure. And the last thing, and those are my 5 points, but this is, if you had to do this work in a commercial space and you had to pay by the byte, it just wouldn't be possible. Tom talked about storage and compute, but the transit costs of this endeavor would simply be prohibitive. And we are able to sort of stay ahead of the curve and make sure that we are always anticipating what the community needs before there's a disaster, right? And so that's an important thing, and that the growth of our network and some of its distinctiveness, in fact, what defines us from a common carrier is our engagement with the research community, and that engagement then in turn helps enrich what we do for all the other communities that we serve. So it makes us a better network, and it also makes us a distinctive network as well.
Right. So, a few minutes for questions?
Yes, we have absolutely time for questions. And I will, as usual, run the mic. Do we have questions from the audience?
You're supposed to have the first question, Jeff.
Oh, well, I will ask the first question then. So how do we then, as people who are advocates for the Pacific Research Platform and now beginning to penetrate into the National Research Platform, or TNRP, how do we do learning transfer in some of the ways that maybe Anne talked about to the regionals, so that we're not, they're not making the mistakes or spending time on things that we know maybe not be so fruitful? What are some of the panelists' thoughts about how we might take some of those lessons learned, both at the micro and then at the macro scale, to the NRP?
I don't include you. Well, we're learning. I mean, we really don't. We have a few clues, but we're just learning, and it's very hard. Tutorials are kind of an overkill way of doing things. They just having a bunch of people in a room looking at PowerPoints or even typing in concert is nothing like having hands-on help, but that doesn't scale very well. The one thing that we've been doing is building these Jupyter Lab experiences that are workflows that you walk through, and there are things that you can glean from those. Maybe we've been talking to Nadia Williams yesterday about how can we do a a series of those are sort of like hello world things, where you get the basic thing, you get something to respond to you, and then you add pieces. I think we have to map all of this into things that people can use quickly, and we're just discovering that. We'd love to get funded to do that. We're not really funded to do that at the moment, but it's a necessary thing to do.
And I know that we're making a distinction between scaling and replicating. We're not scaling the PRP.
Yeah, so that's certainly been the plan, and certainly towards the GRP, we wouldn't want to do that. The idea, this concept of too much information for PowerPoint is actually very deep, because there's you can get 25 by 25 institutions on a slide, in a mad dash. It turns out you really don't want to be monitoring more institutions than that on a mad dash, because you just start tearing up too much bandwidth. And so how do you? Then you say, well, let's have 25 by 25 in the Great Plains, in the Greater New York area, et cetera, and then have them communicate subsets, and the people who are actually part of these namespaces that have the groups that want to work together, that frankly don't care about anybody else, to have them have their own little, health diagram. And that will fit on PowerPoints, and that you can take to your colleagues, at your cryo-EM conference or something, right? So that's the reason I think we want to replicate this thing, not only regionally, but in application fields and domain science areas. So people care about that piece of it.
And I would just add, as far as information sharing and scaling, I mean, Tom, you do a great job of running the weekly calls with the network engineers. I think that there's space available for people to at least listen in, if not actively participate. You can learn a lot that way. I know you're piloting like a Slack channel and, other resources that are available on the PRP website. Those are all good places to get started, and at least to start figuring out to whom to address your question.
So by the way, John Hess and more lately John Hicks run those meetings on Thursday morning. I just take the notes. So.
Any other questions, or are you just all really anxious to get to
It's lunch?
All right, well, as a direct beneficiary of both this panel and the larger work of the Pacific Research Platform, I would like to thank the panel, and then we'll have a few closing remarks. So let's thank our panelists.